All right, so you would plug in n plus 1 and then put it over the series itself and then do the reciprocal. All right, so we all got here? All right, so what is going to cancel? Good, so we'll have 4x on the top, and actually that's it. So this is n squared. If you multiply this out, that would be n squared. So they are the same. That means you use the coefficients, which would be 4x over 1, which would just be 4x. What's the absolute value of 4? 4. And this has to be less than 1. So you would divide that 4 over, and you get absolute value of x has to be less than 1/4. So your radius of convergence is 1/4. So see, that's how it can turn out to not be 1, is if you have like another number thrown in there. But again, usually it's 1. Go ahead. Yeah, because the ratio test, like that's its rule. Like the ratio, like that's the test for the ratio test is less than 1. That's why it oftentimes comes out to be 1. But if you throw another number in there, then that changes it. Correct. So again, we're centered at 0, and we can go 1/4 in each direction. Drawing that number line is like not a requirement. I just do it because I'm a visual person, and I think it helps while I'm explaining it to you guys so you can see what's going on. So we're going to test each of those. You're going to let x equal -1/4. You're going to plug -1/4 back into the original problem, plug it in 4x. So 4 times -1/4, that will be -1 to the n over n squared. I'm not going to write this out again because we did this exact same problem on the other side of the paper. What did this come out to? Converges or diverges? Converges by the alternating series test. Again, we did literally that exact same problem on the other side of the paper, so I'm just not going to write it out again. Yeah, go ahead. Yes, that is, yeah. Like MVT for mean value theorem. A lot of the theorems, they let you abbreviate like that. Interval of convergence IOC, I've not seen though, okay. And then we're gonna let x equal +1/4. 1/4 times 4 would just be 1. 1 to the n would just be 1. So 1 over n squared. And again, I'm not going to write that out again because we literally did that exact same problem the other side of the paper, but we found that that converges as well because it's a p series. P equals 2. So our interval of convergence is that we're going to put brackets on both of them. So that's what it would look like if it didn't come out to 1. Can you put that away for me? Thanks. All right, so we're going back to number 4. And we're going to start with the ratio test. So plug n plus 1 in for all this. Do you see that -1 to the n, that first part? We can actually ignore that. Why do we get to leave that part out? Yeah, and it's alternating, but we're going to absolute value it anyway. So you don't need that part. All right, so this would be x to the power 2 times n plus 1 plus 1. We'll distribute the 2 and combine all the like terms. Just hold on a second. All right, over 2 times n plus 1 factorial. Again, you're plugging n plus 1 in everywhere that there's an n. And then that's all over the series itself. And again, this is one of those things, it's just a lot of writing and it kind of looks scary, but the math that we're going to do is like distributing a 2, if that like calms you down at all. Like I realize it looks awful, but you can all distribute a 2. You're going to be just fine. All right, so let's see. This will be x to the power. If we distribute that 2, that'll be 2n plus 2, but then plus 1. So 2n plus 3. And then this 2n plus 1 factorial is going to come up to the top. And then all the stuff in the middle goes on the bottom. But again, you want to kind of line it up. So I'm going to put that x to the 2n plus 1 first. And then this will be 2n plus 3 factorial. That looks a little better. And you're like, yeah, Miss Cole. All right, so whenever you divide, you subtract your exponents. So if you take this minus this, the two ends are going to cancel. That's gone. Squared, good. 3 minus 1 is 2. So limit n goes to infinity. We have x squared on the top. Now, let me write this out on the board. I know that won't show up on the video, but here's what we've got going on here. 2n plus 1 factorial. So you have 2n plus 1 times 2n times 2n minus 1. Again, think of it with an actual number, like 5 times 4 times 3 times 2. In the denominator, it starts with 2n plus 3. Do you see what I'm getting at here? So all of them are going to cancel except which two? Yeah, do you see how these cancel and these cancel, and then everything from there on out would cancel? So in the denominator, you've got a 2n plus 3 and a 2n plus 2. I just like barely fit that in there. So we've canceled out. Now we're going to evaluate the limit. As n goes to infinity, down here in the denominator, n is getting bigger and bigger and bigger and bigger and bigger and bigger. It doesn't matter what x is. If the denominator is exploding like that, what does the limit go to? 0. This is going to equal 0, which I wish I had space to put there. And 0, last time I checked, is smaller than 1. So we found that that converges all the time. So what is our interval of convergence going to be? Like, which one of these situations have we got here? Like, if it just works all the time. R is infinity, and so your interval of convergence is everything. Because we just got that it converges all the time, like it just works. 0 is smaller than 1. Which is really nice, because then you don't have to like test endpoints. Like there's no other work, so that's fantastic. Yeah, you're good. Yeah, let me sign your pass. So this is the one that's centered somewhere else. Where is this one centered? At 2, good. But we're still going to do the problem the same way. It's just centered at 2 instead of 0. All right, so start with your ratio test. So we're going to plug in n plus 1. It's always nice when you don't have like a fraction and then another fraction in a fraction. Like this is a lot easier. So the 3's are going to cancel. And then actually all of the x minus 2's are going to cancel except for 1. And so actually all the n's are gone. So the limit doesn't really matter at that point. It's just going to come out to absolute value of x minus 2. And that needs to stay smaller than 1. And that's just by definition. It's always going to be less than 1 because that's your ratio test. So you're, yes, okay, so hold on. You're exactly what I was going to say next. No, you're perfect. So our radius of convergence is 1, but we're not centered at 0. We're centered at 2. And we want to be 1 unit away in each direction. So that would give us 1 and 3 as those endpoints that we have to check. And so if you were to work this out, you would get 1 and like, this is exactly what you're saying, like 1 plus 2 is 3. But then if you did the negative 1 plus 2, you would get 1. So I like to write it out this way because visually then you can see it. So let's test 1. Let x equal 1. You're going to plug 1 in for x in the original problem. So that will give you 3 times 1 minus 2 would be negative 1 to the n. All right, that is an alternating series, but you don't really need to do an alternating series test. If you were to list out some of the terms, you would get 3, negative 3, 3, negative 3, 3, negative 3. Are you following me there? Is that going to converge? No, that diverges. Not by any particular test. it's just 3 plus -3 plus 3 plus -3. Like, it's just not going to work. If you were like, you know, on the AP exam, they would just take diverges for that because there's not really any explanation. If you felt like you wanted to write more, you could write 3 plus -3 plus 3 plus -3 to show that you thought about it. Yeah, or you could write it that. Yeah, I think they, in this case, because that's such a weird thing, they would take just diverges. But yeah, you could explain it that way too. I would probably just write out the first few. A similar thing is going to happen with +1, or sorry, we just did +1 with 3. If you plug in 3 for x, 3 minus 2 is 1. 1 to the n is just 1. You just get 3. So that series would be 3 plus 3 plus 3 plus 3 plus 3 plus 3, which is also going to diverge. That's just going to keep getting larger and larger and larger. I guess you could do an nth term test, limit as n goes, like it's just going to keep getting bigger and bigger. You just keep on adding 3. But I think that's good. So what is our interval of convergence? Parentheses 1 to 3.